Record to computer. All right. So this I think is probably like what I would call, I mean, this is easily like an A kind of paper, right? Or an A presentation. One, aside from the aesthetics of the deck itself, right? So we have some clearly defined research questions in here. Um, so in this case, right, like, so what roles do SES, school funding, and enrollment play in public education? Um, right? And further, is there racial disparity in public education? And so she posed a question um, that socioeconomic status, funding, enrollment can have both positive and negative impacts on public education. Further, that there is this, sort of racial disparity present in public education, right? So that's kind of that's the statement that she is positing. Um, so that is the hypothesis. So the research question would then become, right, to what extent do these factors have an effect, right, on public education? So one, is there an effect? And then two, is it positive or negative? And then secondly, is there a racial disparity in public education? Um, the big thing with this, and I think really what is more crucial for you guys is, right, like defining the data, right? Defining the data for the audience, giving us an idea of what it is that you're working with. One, it's to build credibility with your audience. So if you're thinking about, if you've ever been in any kind of debate, right, around a topic, right, it often ends up becoming a race against what source are you using versus what source is the other person using, and the credibility of those respective sources, right? Sort of like, oh, what, pick any particular topic, whether it's gender issues or an economic problem or a political problem, right? Um, right. There's vibes and ethics, right? We kind of know like what we want to do, but right, what does the data show, right? Like, do you have proof that what it is that you're talking about actually exists? And um, those types of debates often come down to, right, like, oh, like, what study are you using? Where are you pulling your data from? Is what you're saying in fact actually true? And what those all kind of devolve into is describing the shape of the data. Like, what does the data look like? What sort of shape and form does this thing have? Which is sort of kind of a weird statement to make, right? Data is an abstract thing. Like, how can it have a shape? Well, it does have a shape. And that really has a huge influence over, the sort of conclusions that we draw from our data. And so one, it's to build credibility, with our audience, but then two, it also frames the question in a way that we can actually have a productive conversation about it. And it helps our audience become engaged with the question at a more personal level. So if you're thinking about, a question around, let's say, child poverty, you guys, child poverty is a question that has really kind of come out of this data set. Why do I want to even think about paying attention to child poverty? Like, yes, okay, moral questions aside, right? Like, it's sort of, I'm not trying to, suggest that it's okay for children to be poor, merely that, child poverty is a thing that exists. But, given all the different, competing, competitions for our resources, why do I want to focus on this particular sort of element of it? um, Helping the audience understand sort of the magnitude of the data, right? Helping them understand that why this is an important issue, but then also uh, giving them enough information to sort of trust that, right? Like, I can sort of take this data for granted, and rather than focus on elements of the data, we can immediately start going into the actual arguments themselves. And that's really, I think, kind of, somewhat over. It seems a little wonky, right? Like, we kind of get into these tables of statistics, But they really help us sort of get past this fundamental issue of data and help us get right into the argument. And so, the first thing that we want to do is define our data, right? So what variables are we looking at? Where is the data coming from, right? Um, what is, what's the source, specifically like which data set, right? What does that data set represent? So in this case, she's using the Stanford Education Data Archive, um, right? Which, and then it's a data set, it's got student performance for each school district in the US for grades 3 through 8. So it's a very comprehensive data set. And she's also pulling in the Census Bureau data, like what you guys are using, Tidy Census, as per pupil amounts of spending of public school systems by state. So she's using two very large data sets. And she's further defining that. She is using data on the types of students, the standardized test scores, their improvement rate, right? Sort of defined somehow. And it might be worth maybe expanding on sort of what this metric actually means. That could be an important part. Socioeconomic status, and then the enrollment and funding amounts by, I assume, school district, um, or I'm sorry, by the so enrollment, I'm guessing, is going to come from the Stanford data, and then the funding is going to come from the state level Census Bureau, right? So immediately, like, we've got a pretty good idea that these are coming from some pretty big reputable data sets, that there really isn't a quality issue with the data, and that you've now focused my attention on, okay, I'm looking at a very narrow, right? We've really focused our attention on these particular variables and these particular data sets. Um, and then secondly, what does the shape of that data look like, right? And by the shape of the data, what do we mean? Well, if I go back to this bar plot, right? Um, this data has a particular shape, right? So we can see that there are some sort of seasonal factors, right? Like if I just look at this kind of, take a step back and just sort of glance at it, there's kind of a seasonal effect here, right? That in the wintertime around December, right? Like there's a spike in delays, and that there's a spike in delays in the summer months. And then, to some extent, right, there's a little bit of noise here in the spring. And so, what are some of the two biggest travel times of the year in the United States, right? The summer, when everyone's taking a vacation, right? Like, what happens in June? Well, June is when everyone's out of school and everyone starts taking their summer vacations, June and July. And then what else? What happens in December? Well, that's the holiday season, and that's also when everyone is traveling. I think was it the two of the busiest travel times of the year are Christmas and Thanksgiving, right? When everyone kind of flies across country to go visit their family. Right. So this is sort of the shape of this is kind of the overall shape of the data, right? This is kind of what it looks like. And we can do that here by using different styles of summary statistics, right? So in this case, we've got mean, median, the standard deviation, min and the max, and the count, right? And so, these are sort of your, was it 1, 2, 3, 4, 5, 6, right? These are like really your 6 critical um, summary statistics that will give your audience a fairly complete view of the data, right? So do you guys, just kind of recover, do you guys understand the difference between mean and median? Alyssa's saying yes.
Yes.
Yes. Yeah. So mean is just the average of the data, right? So I have 25 observations in this data set. And I'm just going to take an average of whatever socioeconomic status is. Median takes those 25, it orders them from smallest to largest, and it just takes the middle, whatever that middle value is, right? So whatever that middle value is the median. Why is it important? Well, if I have extreme outliers in my data, right? So for instance, if I have a ridiculously high number or large number in my data that's going to have a massive effect on the average, right? So if I have, let's say, a bunch of small, 24 small values, and I've got the last one some ginormous value, right? My average is going to be just blown out. Whereas with median, it's considered a more robust statistic because regardless of what that one data point is, right, in our data set, it's not going to change the fact that the middle value, that 12th or 13th value, is always going to be the same, right? So median, comparing mean and median give us an idea of what the skew, what we call the skew in the data set looks like, whether or not it's skewed. So in this particular data set, we see the mean socioeconomic status, again, whatever that number is defined as, is zero point 0.3 and the median is 0.2. And so what we would say is the data has a positive skew of roughly, let's say like 0.1, right? We wouldn't say 0.1, we just say roughly that the data is skewed positively, meaning in this data set, right, there are a bunch of smaller values, but then at the end I have some amount of right these larger values in our data set. And if you think about how society is structured, right, like what's the one thing that's in the news right now, right? The Elon Musk becoming like what the first trillionaire, I guess, ever, or at least publicly become the first trillionaire. And that's created this huge discussion around socioeconomic status and wealth, and how, right, like, if you think about, if you sort of, you think socioeconomic status and wealth are kind of roughly the same, right? That you have this vast, big population, right? That's at some level, but then you're always going to have this sort of much smaller slice where, their socioeconomic status, their wealth is going to be, much, much greater. And so that's going to blow the average out. Whereas the median is always going to kind of give you this idea of what sort of the average or representative individual looks like. Um, you understand standard deviation? Right. So so the mean and the median are what we call like our centering statistics, right? So it tells us where sort of the data is located, right? Like that tells us where things are, right? Where we're going to find sort of our most values. The standard deviation tells us how wide that data is, right? How much spread there is in that data. And so if I were to take let's say, if I were to go and do a survey at Spelman and I were just with a tape measure and just started measuring everyone's heights at Spelman, right, as people kind of walk in between classes, I would probably get something that is fairly tight, right? Everyone's kind of roughly the same age, everyone's the same gender, right? Like you're gonna see some tall folks, see some short folks, but for the most part, right, you would expect to see the data to be fairly tight, around a certain value, right? What's the average height for female in the United States? Was it like 5'4"? I don't know, whatever it is. Um, if I were to go over to Morehouse and do the exact same exercise with the gentleman, measure their heights, I would then get, another number, right? And I would also expect it to be relatively tight. And I could kind of compare the two, we can make comparisons between both populations, but I wouldn't expect in each the data to move a whole lot, right? Compared to, let's say, I don't know, economic outcome or income or give me another. What's another? You know, there's a lot of variability. I don't know. You can, for lack of creativity, we can envision a situation where there's just a lot of randomness in our data. Um, uh, let's say, how long it takes us to get to work in the morning, right? Like we live in a high traffic area. It's really unpredictable, right? You know, let's say how long it takes us to get from one MARTA station to our destination, right, every morning. And, MARTA is kind of, again, famously, sometimes lacking in reliability. And so we may see a much wider spread in the data if we look at those times compared to like another data set like heights or whatever. But standard deviation kind of gives a sense of how wide the data is. Um, Another thing you guys may not sort of think about in terms of, but is also important, is uncertainty. So thinking about standard deviation as a proxy for uncertainty, which is, I think, kind of how at least I think about standard deviation and really kind of how we communicate standard deviation. Um, so if you were to think of this data, right, as being part of some random number generator, right? Like if I were to just pull a random individual out of the population, right? How certain would I be that their height would be somewhere near the average, right? That's kind of what that standard deviation represents, right? How certain do I think that that value is going to be near the center of the distribution between either the mean or the median, or rather, I'm sorry, near the mean. Um, that's another way to think about it, right? So, like, how informative is our data, right? And so the wider that standard deviation, right, the less informative the data is, right? Because the wider the standard deviation, if I were just to randomly choose one value out of it, or if I were to do another sample, right, pick a whole new sample, um, right, my value, the wider the standard deviation, the the more random that new observation is going to be, as opposed to being kind of located closer to your average. Um, so that's kind of one way. Min and max, again, sort of just defines how our variables are kind of either bound or defined. Um, this is also sort of a good smell test. If our values are supposed to be between, let's say, 0 and 1, and if I were just to do these three statistics, I might not blink an eye. Okay, yeah, sure, there's probably some extreme outliers. So my mean is going to probably be higher than my median. Maybe this is, a variable that just has a lot of noise in it. So perhaps my standard deviation I would expect it to be high. Um, but let's say, it's supposed to be between 0 and 1. And so, okay, these are all positive. They're less than 1. They're greater than 0. All right, we're doing good here. But once I plot this min and max, or run this min and max, right? I've got a negative 1.24 and a positive 1.79, right? Like that's okay. That's not between 0 and 1. Like that's something outside of what our value should be, right? So this is sort of a good idea for us to run to understand, okay, are there any data quality issues, right? Is there some filtering I need to do? Is there some other stuff? Um, are these variables coded in a certain way that where they may be right outside these, a 0 and 1. So, for instance, let's say that min and max are supposed to be between 0 and 1, but if the value is missing, then it's coded negative 99999, right, or something, right, something like that. And the reason why we do that is, back in the day, with these statistical packages of like Stata, like R, right? But I'm talking like back in the 70s and 80s. Um, Handling missing values is very, very challenging and very difficult, and these programs just had a really difficult time managing it. They really didn't have NAs, and so the way that they would handle a missing value is that they would plug in an extreme value that we then as researchers would go in and filter. And so you may have that, or some extreme positive value to represent some other special case in the data set. And so being able to filter those out becomes important, so you don't end up with, right, things that are, outside of your range. Kind of a small test for you, but then also, right, for the audience to show that, hey, right, these are supposed to be 0, 1. In fact, I have values that are, between these two. Things are kosher. And then lastly, right, the count, right? So why does count become important? Can you guys sort of envision a reason why? Like, I want to show count. Question anybody. So I got 25. Like, why do I want to tell the audience I've got 25 observations in my data set?
So they know how big the experiment was, so maybe how accurate it is.
Yeah, exactly. Yeah. So statistical significance, right? Like, so if I'm working with a lot of data, I can be reasonably confident that the numbers I'm getting out of here are are representative of what we call the population. Close my door here real quick. Um, right. So when we run statistics, and when you get deeper into your statistics classes, there's this thing called a population and then a sample. And we think about like population as like kind of just vernacular, as sort of being like the data we're looking at, right? So census, right, create statistics about the US population, but they're doing that by taking a sample, right? They're not actually going out and asking literally everybody, like, okay, so, what's your income and how many people live in your house and all the other features. They're taking a random sample, a much smaller random sample, and having people go out and perform these surveys, then using statistics that they know about sort of the composition of the various demographic compositions of the population, to then extrapolate, right, what that means for the bigger population. And so the more data you have, you can think about it in terms of being more representative of what the population would look like, right? So um, you know when you have a small number of observations, if I were to take another 25, right? If I take another 25 observations, right? If I run this survey again or run this sample again and randomly choosing another 25 observations, how likely do I think that the statistics here that I get would be close to or the same as, right, my original 25 observations? Right? And the fewer the data points you have, the less certain you are, to have those values kind of line up, right? And so, you can think about, again, like, heights. I don't know if you guys have ever been to the Midwest, like the upper Midwest, like in Michigan and Minnesota. Dude, those people are giants. They're tall. It's hilarious. Uh, you know, I'm 6'4", and I was like, aha, I found my people. Like, everyone is just like, there's huge up there. And so if you were to take a sample of average heights up in Michigan, your data would just be completely blown out. And if you were to rerun that sample and you happen to pull from just another part of the country, let's say like the Southwest, you're probably going to get very different values. And so, yeah, so these sample sizes tend to, the more data you have, the more comfortable the audience can feel that, the numbers you're seeing are more representative of what the population would look like. Um, Let me see here. So on this one, right? So, again, kind of going back to our examples here. All right, what's a good chart look like? Title, axis labels, right? And then some kind of descriptions on it. They can make it look clean, make it look clean. So how do we get to these statistics? Well, one thing we can do is, let me pull up R real quick. Let me see. let me switch gears. R. That's not what I want. Where am I? Where's posit? Posit, posit, posit. My class notes. Here we go. And resume. Just give me a moment. Do you have any questions about kind of what, the summary? I mean, the summary statistics, these are fairly straightforward. Like you've probably run into them before, like if you've taken stats in high school or you've taken an intro to stats class already. Like that's, I think, like the first unit kind of material, right? Like we're not doing anything exotic. We're not running any tests. This is just literally describing what our data looks like. So how do we go about doing that in R? If you don't have it already loaded, we're going to be using, right, tidyverse. Let me see what I'm going to do. NYC flights 13. So I'm putting these in comments, guys, because I already have these packages loaded. But if you don't, you want to run these two. Library, NYC flights 13. So if you don't already have these installed and loaded, you can just go ahead and uncomment them. And then data, is it NYC? No, it's data flights. Right. I think the flight flights. Yeah, so we're going to be running off of flights here. So if you were to uncomment and run this line, that would get you to the data we're working with. So if we go ahead and examine what that data is, again, right? So we just got a bunch of stuff in here. I've got 336,000 observations. That is way too much data to possibly, right, kind of get our minds wrapped around in an intuitive sense, right? We really need to start doing some math here. And so the way that we can do that is simply with the summary command. So I can use the command summary. Summary provides a lot of those statistics for us. It's a very low level function. This kind of goes back to the origins of R, right? This is in what's called the base installation, right? This is kind of comes prepackaged in R already. It takes an object and it's going to spit out a bunch of statistics about that particular data. So we can see here that if I just do start with let's see if I start with flights, going to do a pipe. Let's do select. What data do I want to look at? Flights. Let's say I want to do let's do departure delay, and I don't know what else we want to do. Airtime. Let's just do departure delay and airtime, right? So departure delay is the average delay in minutes. That's calculated by just simply the difference between when they were scheduled to leave and when they actually left. So departure time, scheduled departure time. The difference between those two is departure delay. And airtime is just the total minutes that the plane spent in the air. So once it took off and then landed. So just for example, let's go ahead and look at these two. So if I do, was it departure delay? Departure delay, dip delay, and is it air underscore time? Okay. Time. All right. And so if you remember, There are NAs in here. All right, so uh, flights that were canceled had NA values in their data, and that's going to completely mess us up. So if you remember, anytime we have an NA in our data, um, it's going to show up as an NA in our statistics. So let's go ahead and just filter those out. We can just filter those out simply with a command called drop NA. So what drop NA does is it goes down into the data, it looks at the row, and if in that row it sees in any one of those variables, right, an NA, it just immediately drops the row, which is kind of exactly what we want to do. And let's see, then we're going to just pipe that directly into a summary. If I do that, right, if I do that down the bottom, right, I get these statistics, right? So I get departure delay and airtime, right? I get their min, their first quartile, median, mean, third quartile, and max, right? So I get the min and max. I get the first and third quartile, and then the mean and the median. Right? So summary kind of just does the work for us in some sense, right? It's awesome. There's so much less where I don't have to go through and do mutates and calculate a bunch of points. I don't have to, right, deal with other functions. I can just immediately pipe everything right into a summary, and it will give us those statistics for us. Now, you probably may have noticed, maybe not, what is missing here is standard deviation, right? So standard deviation is one metric that we use for the spread of the data, right? That's kind of one metric. You can also use the difference between the first and third quartile. So we call that the interquartile range. And that's another way to describe sort of the width of our data. And in fact, some people I think may prefer the interquartile range as being a little bit more robust than maybe standard deviation. The you know, are you guys familiar with the concept of a quartile? All right. So I just literally take my data. If I've got let's say 25 observations, I split into 4 equal buckets of observations, and then where those breakpoints are the quartiles. So I've got the observations from 43 to -5, like those are going to be in the first quartile, so on and so forth. We're also missing the number of observations in here as well. Let's see if we can add that in here. We do not have n. Let's see. Do I have factors? I do not have n in here either. Can change the quant cell type. Can do factors. However, we can also do other things as well. Let's go ahead and say, I can also do flights. I can do select, got delay, air time. Let's go and drop our NAs, right? But if I wanted to do these sort of individually, right? So if I did want to add the standard deviation, if I did want to add the number of observations, I can immediately just drop this into a mutate, right? Or I just do a group by. I don't want to do group by. Let's do. We could just do summarize. Actually, let's think about this. We can do better than this. Let's use our pivots. I remember I'm inspired by Malia's code. She had I think she had used a pivot in her summaries that she showed us on Thursday. So what I can do here is I can throw this into a pivot longer, right? So if I look at my data here, let's just look at this data for a second and comment this out. I should have 2 columns of data, right? I've got departure delay and airtime. So I can pivot longer and I can do names to equals variable, and values 2 equals, I'm just going to say value, right? So I'm going to end up with, instead of having 2 columns of data, right? So where the header has got the variable name, and then each row has their values. I'm now going to have a 2-column data set. One is going to have the variable name, and then the second one is going to have the value for that data set. So if I do that, am I going to get anything out of here? Let's see, is that going to work? Nope. Ooh, I cannot do that. Yikes. How can I? If I could do that, am I mistaken? Oh, let's look in here. I cannot. So I'll tell you what, the way we work around that is, let's add a row identifier here. And equals 1 to n. So I'm just going to add a number observation in here. Actually, do I have other data that I can use? Do we have other unique data in here that I can use? Perhaps. I'm not sure. I don't see any unique identifiers in here that I can use to anchor my data. So I'm just going to go ahead and add one. So I'm just going to add like an observation number in our data set. So you can think of, 1 to however many data points are in this data. I guess, what is it? 336,000 or so. All right, I'm gonna have 3 columns of data now. So if I go look at that, right? So I've got the number of the observation number, and then I've got the values associated with each. Why do I want to do that? Well, you're going to see here in a second. So I'm going to do a pivot longer, data frame pivot, into longer formats. Okay, let's see. Let's do calls equal let's see how this works. Is that going to give me anything? There we go. There we go. Okay, excellent. So I'm going to pivot longer. I want my columns to be departure delay and airtime. I want the names of those variables to go to variable, and I want those values to go to value, right? So here I have for each observation, right? Observation 1 had a departure delay of 2 minutes and an airtime of 227. Why did I want to go through that effort? Well, I'm going to show you why. So I'm going to now pipe this into a group by. And I want to group it by this variable, right? I'm going to group by variable. And now I'm going to put that into a mutate. And now I'm going to run my statistics, right? So I can do, let's say mean val equals mean of value. Right? I could do median value equals median value. And then we can do, what's another one? SD val equals SD. Oop, yikes. What did I just do? Holy smokes. Let me, there we go. Where's my other stuff here? How do I get back to that? View. Panes, show all panes. There we go. Now we're back. SD value. What's another one? Min value equals min value. Min value. Max val equals max value. And then what was this? and value equals n. Right. So what does this do? So I've got this summary here that provides me some summary statistics, although it's a little bit limited. If I want a bit more expansive list of statistics that might be a bit more, I guess, kind of germane to my data, what I can do is I can, rather than having to type this out for each individual variable, I can use this pivot longer function that we talked about last week, right? I had to do a little bit of work, right? Because I got to give it sort of a unique identifier that R knows how to sort of anchor on and knows how to pivot on it. But once we do that, we can then group by the variable and then just run our statistics on the value. And so when I do that, what I should get is my first row of summary data should be the variable name. And then the subsequent rows of data should be the statistics that we calculate here. So if I do that, that's exactly what I get, right? So this is kind of nice. Wait, hold on a second. That's not at all what I want. I want not mutate. You guys didn't catch me. I want summarize. I want summarize. What mistake did I just make? I made a rookie error. You guys didn't catch. You guys had me dead to rights on this one. Mutate, remember? That edits each individual row of data, right? Summarize the whole data set. I want to summarize. Can't believe I actually like I caught me in a. Told you I'm off my game today, man. I'm not at my best. Just gonna clean this up a little bit. And there we go. All right. So if I run that, there we go. That's better. All right. 2 rows of data. First one's variable, right? Airtime, departure delay. I get my mean, my median, standard deviation, my mins, my maxes, and I get my I'm calling it nval. You can, number of observations, whatever you want to call it, right? Let's call it nobs, number of observations, right? How many observations are in my data set, right? So if you wanted to show your audience, right, like what was fairly descriptive about your data, like this is a good table to have. If you wanted to add, any of the quartiles, right? So the quartiles are like our or let's see, for the quant. If you want to add quantiles, so you can do quantiles in terms of like quartiles or quintiles or terciles, right? You can split the data up however you want to. Get mean, median, min. I can do was this the I can call this a first quartile. So I'll call this say Q. I'm gonna call this Q1, right? Equals quantile, and I can put in value. And then let's look at this. Let's look at the function itself. All right, so quantiles are ways of producing like quartiles or deciles or whatever it is that we're looking at. So it takes in 2 arguments. Like the first one is our data, and then the second one is our probability. So if you're looking at quartiles, right, you're going to be thinking of 25%, 50%, 75%, right? If you're thinking of deciles, it'd be like 10%, 20%, 30%, 40%. Typically, we look at quartiles. We just divide up into fourths, but you may need a little more granularity in your data. Here, we're just going to do the quartile. So I'm going to put in value, and I'm going to put prob equals 0.25. And then let's say Q3 equals quantile value prob equals 0.75, right? And if I do that, right, right, I get the values for the first and the third quartiles. Does that kind of make sense? Yeah. again, we're using sort of the things that we've already kind of learned in this class, right? So doing summarizes, summarizing, doing using the summarize function, using our group bys, um, getting a little sophisticated here with this pivot. This pivot longer is it's a little bit fancy, right? It's kind of showing that I don't want to do all the work myself. I want to let the computer actually do the work for me, right? So we're letting it group by our variables of interest to produce these statistics. Um, but then using kind of mean, median, right, standard deviation, so on and so forth, to then go through and kind of give us a shape of our data. The only thing that's a little funky here is this quantile function here, which we really haven't done a whole lot with, but is particularly nice. Again, all this does is just splits our data out into probabilities, right? So if I think I've got this distribution data, right, what is my what probability is associated with the first and the third quartile? It's going to be the 25% and the 75%. Let's see now what else. And then we get this data down below. So like for your first right kind of chart that you guys are produce, this would be a good place to look at. Like this is something that is kind of what I'm looking for. Question for you guys: is this pretty or ugly?
Ready?
Nah, it's ugly as hell, dude. I got underscores. I got all kinds of junk here, right? It's like so they did some rounding, right? And it's got some color. At least they color coded the negatives as red, right? So there's that. But if I just took like this and like if I just like screen cap this here, um, right, and then let me open up my thing here. Blah, 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 blah. Where's my desktop? Let me see. Let me share this up for you guys. All right, if I just where's my share? Right. I mean, if you just saw this on a screen, right, this is kind of ugly, right? Yeah, I don't think that's too particularly like kind of nice. Like it's kind of weird. I mean, it's fine. There's nothing wrong with it necessarily. But you know, meh. I don't want to see this. I want to see commas, right? I want to see right a nicely formatted chart. So what you can do here, let me give you guys a little pro tip from. Come on, there's my screen. Give you guys a little pro tip. Share. What you can do with this, which is particularly nice, is I can just, I've got my summarize, and usually this is where we stop, or like we'll go to like a ggplot. I can export this data, which is even better. I can do what's called a write underscore CSV. I can call this summary stats.csv, right? And that is going to create a file in my my files section here called summary stats. And what I can do is I can then download that. So if I go to more and I go to export, right, it's going to ask me if I want to download it. Yes, I do. So I want to allow. All right, very good. Let's go back over to here. Let's see. Let's go over to here now. Where I want to go? Where's my? Go to summary stats. All right, let me share this up here in a second as soon as it loads. So that's going to download something for me. And then now I want to, come on, is it going to load or not? There we go. I'm going to share this up, right? So now I've just got a simple Excel window here. Let me make this bigger for you guys, right? And so now I've got something that's in like an Excel spreadsheet, right? And so from here I can type in, maybe I could just leave this blank and I can do mean, median, Standard deviation, min, first quartile, third quartile, max, and observations, right? And I can like center this. All right. Or if I want to, like if I don't want it going across, if I want it going down, right? I can do a paste special, do what's called a transpose, right? So now I've got it going lengthwise. So I got airtime across the top and departure delay. And departure delay minutes, right? So this is a bit more informative, right? I'm not looking at console output. I'm not looking at, right, some computer code. My audience, does my audience need to know what computer code looks like? Perhaps not, right? Do I need my decimal precision down to this level? Like perhaps not, right? So I can shorten this up, maybe to 2 decimal places, right? All right, and then I can, make this look pretty, right? I can put a box around it, whatever, right? Go to view. How do I get rid of my grid lines? How do I get rid of my grid lines? Page layouts. Where's my grid lines? And get rid of my grid lines, right? And let's say here now I want to like just do a little quick screen cap of this. All right. If I share this up, well, make it a bit bigger. Share this. All right. Does that look a little bit better? All right. I still got a little bit of work to do, right? But this is like in 5 seconds, right? Like I just took our table, dumped it into Excel, right? And then in Excel, I can do like a lot of really nice formatting. It ties into PowerPoint really nicely, so I can do something fancier there, right? But like, again, like this is a lot more, I think, informative than simply looking at whatever this is. Like for our audience, they're not going to know what the hell this is. Like we know, like because we're in the data and in the class, like and people in the profession, right? Like we're going to know what this means. But yeah, for the layperson or for your audience, these things end up becoming like more of a distraction a little bit. It's kind of take the 5 seconds and just dump it in Excel. It's kind of the TLDR there. The too long didn't read. So do we have any questions? I've hit you guys with a good bit of info. I want to pause and let the room breathe for a second. Anybody? My explanations are so superlative that we just get it 100%. I'm that good of a teacher. I find that hard to believe, but my code is available if you guys want to go through it. But these are both acceptable ways to produce these outputs, and you can do the same thing here if you want to. Right? You can do a let's say write CSV. CSV. You can do both here, right? You can output that and then massage it later. Again, between these two, like which one do I prefer? I prefer this second one, right? It's a lot more prescriptive. It tells me a lot more about the data, right? I get a number of observations. And, if there's any other sort of, variables of importance, they can, you can kind of surface those in these stats. For instance, if you had, the presence of like unique groups, right? Like, so there's some subgrouping in your data that you want to call out, right? We can you know do the number of like unique groups that are in there. Um, a whole host of other stats that are important for our audience. If you guys have questions around those as you're getting into your data, like let's say for instance that you've got your data broken out by let's say county, and you're looking at school achievement. um, and so one thing you may want to show is like, yeah, you've got the number of counties that are in there, but within each county, like, what's the average number of, let's say, schools or school districts within each, or not, but the the number of school, sorry, the number of schools in each county. Um, so if I were just to run it, purely just off of the county level stuff, like I probably wouldn't get that information. So yeah, these are summary stats. Again, summary stats just tell us the shape of the data, right? They kind of, give our audience some notion of like what it is that we're looking at, the size of it, what kind of statistical inference I can draw from the data, like how much uncertainty is there, how rich the data set is. These are all things that these summary statistics give us a sense of. They also kind of give us a sense of what the distribution of the data looks like. Is this data that's particularly tight, right? Is it kind of like, height data where I expect it to fall within a pretty tight range, or is it something a bit more broad, like let's say economic outcomes or things of that nature, where we might expect the spread in results to be a little bit wider. I'll say that so for the example we use here, what was it, 25 observations. Let me see if we can go back over to the, here we are. Let me share this up. So here we've got 25 observations in this data set. Is this small number an issue? That's a good question. So if we go back to the data here, includes measurement of student performance for each school district in the US for grades 3 through 8. And then we've got per pupil amount of current spending by public school system by state. So I've got a bunch of averages, and then I've got a count of 25. So for you guys, the data set we're running on is, at least allegedly, student performance for each school district in the US for grades 3 through 8. Is that a lot? Do you think that's gonna be a big number or a small number?
Small number.
School districts? Number of school districts, the number of school is, there's 50 states. How many school districts are in each state?
Yeah, I
Uh,
think number.
yeah. So say it's 10, right? So I should have assuming that we have 10 school districts in each state, which is, not true. It's much larger, right? We would expect, right, this number to be like in the high hundreds, thousands, right? We expect at least a comma in there somewhere. And then we've got Census Bureau per pupil amounts for current spending of public school system by state. So that's going to be at least like 50 in here, right? So something in here. And then we've got socioeconomic status, which I don't see. I guess maybe it's in one of these data sets. So in here, right, if we were to critically evaluate this, so I get the types of students, the scores, and the rate. So these first three data points in here make sense, right? They pretty much obviously come from the Stanford education data set. All right. So demographic information, their scores, and their rates of improvement. Um, so the total school funding, okay, that makes sense. Um, that this would come out of the Census Bureau. Um, but it's less clear. So is this all like the average per pupil spending by state in the public school systems? Or is this a list of all the public school systems in the country with their state data? And it's that output as well. So there, so I've got school district level data in the first bullet point. Do I also have school district level data in the second bullet point? That's less, and can I merge one for one into the other? I don't, it's less clear here, right? It's so I, as the audience member, might ask, well, are you matching one for one the spending data with the education data? 'Cause that's cool, right? If I can match one for one, like I can assign, I got pretty clear data. That's a pretty big scatter plot I can run. Um, if I'm not, and I've got to aggregate the Stanford data into a state level kind of metric, like an average or something like that, right? Then that's a little less clear, right? And it's not clear where this socioeconomic status variable is coming from either, right? So having some sort of indication where this data is coming from and at what level are we doing the aggregation, um, you know, is something that's kind of important to notate. And why am I even going down this, another one of my tangents? Well, I expect this data point to this data should be pretty big, right? I should have a lot of data here. And in theory, I should also have a lot of data for the second one here. But if I go down to my summary stats, right, I got counts to 25, right? So I've got, so, maybe the layperson may sort of glance over that and not really, put too much focus on it or miss it. But if you're in a room full of economists or policymakers, like there's an issue now. There's a bit of a disconnect here, right? Like I've got two big data sets, but then my sample is now really small. So why the big drop in observations here in our summary stats? Like at what level of aggregation are we doing these things? Are you doing a lot of filtering? Because the researcher here may be undercounting the total size of their data, right? And in fact, this observation is much, much larger, right? And generally speaking, the more data we have, the more certain we are of the results that we're getting out of our analysis. If you guys ever, if you're like me and you go to like WebMD or you do a little Google search on, if you get sick, right? You kind of the first two hits are invariably like the worst possible medical cases on earth for what it could be. It's like, oh, I got a runny nose. What should I do? And it's like, oh, you're totally gonna die tomorrow. Like there's no hope for you. It's like, no, I just got a runny nose. Like, hold on. If you ever go into medical research literature, they use a lot of the same techniques that we're using here. So they run the same types of summary stats. They're doing linear regressions. But famously, and sometimes for obvious reasons, their sample sizes are very, very small, right? They're using sample sizes of like 12 or 13 or 20 or, right? Maybe they've got, if the epidemiologist, the CDC may have data in the hundreds, right? But rarely do you ever get these massive, massive studies where you've got thousands or tens of thousands of observations, like what we might have in, let's say, like airport data or traffic data or whatever. And really, what they're kind of leaning against is, again, like for people, medical outcomes tend to be clustered, right, within certain tight ranges, right? Like everyone has a heart and everyone's heart beats, and it typically beats, right? Like somewhere in the vicinity of like, 60 to 80 beats per minute, right? Like there's not much variation there. And so if it does vary, you're now a part of the statistical outlier. And so they can kind of lean against these much smaller sample sizes, or they're looking at a very, very, very unique condition where, by definition, right, you're just going to have a very, very small sample size. But for us, right, like we should see numbers that are a bit bigger here. So that would be sort of the first observation out of that. So when you're doing your summary stats, right, one, again, builds rapport and comfortability with your audience. But two, it's also a way for you to just kind of take a step back and think, okay, do these numbers make sense? Right. And so for us here, right, like the big call out is this 25, given the overall size of the other data sets that we're working with. Does any of that tangent make sense to you guys? Was that clear? Did you kind of get it? Do you kind of get the point I'm trying to drive here? Yeah, yeah. I mean, it's a little hard to kind of get your head wrapped around when you guys start doing this, and you start getting questions around it. It'll make a lot more sense. When professionally, I think I told you guys this story. Was in a meeting. We had generated this gigantic report on all these assets that the company held and their financial performance. And we had this broken out in this ginormous, like 15 by 15 grid, right? With like subcomponents of each. And I had it on one of those giant whiteboard walls that was being projected. And our division president came in, looked at it, just briefly glanced at it, pointed to some random box in the middle of the screen, like, oh, that's wrong. Like just, and it was because it was one of these exercises where like the number just didn't tie out, right? It was like he kind of knew like, okay, what the sort of rough shape of the data should be, and the extremely low or extremely high value that he was calling out, right, was a big red flag. And so, having been burned by that in the past, I think it's become pretty important. So we've got you've got data, you've got a question, you know how to do plots and summarize data and do some changes to it and calculate statistics. And then lastly, we now know how to kind of summarize the data in a way that at the very beginning we can kind of introduce it to our audience. So you have literally all the components you have all the components to basically work as an intern here at the Fed, if you so wanted to. If you want to apply to the undergraduate intern class that we have, this is exactly kind of what these are exactly the skills that you would need. Oh, here's 25 largest schools. So it looks like she limited her question to the 25 largest school districts. Okay. So maybe that explains the 25 then. So this is all the data, I assume. And then she's just focusing on the 25 largest school districts. Perhaps that's it. So yeah, kind of point of clarity worth making. But this is a pretty good example of what is like a really good deck. This is a really good presentation. So if you just kind of follow this format, right? So introduce the question and sort of the hypothesis you're looking to explore, right? In words, describe what the data is and the key variables, summary statistics, right? Start at high level, do some show some kind of summary plots of what the high level data looks like. If you're looking at the relationship between two variables, right, that really lends itself well to a scatter plot. If we're looking at one variable, kind of like we were looking at bank wages data, right, we may want to use a histogram or a density plot. If we're looking at time series data like we were with the New York flights data, right, maybe we want to put like some time component on the bottom and do like some some columns or like a line chart. Um, and then kind of going into like really honing in on what your question is, right? And doing your filtering there. Here, she was using the Geom Smooth feature to plot the line of best fit. Um, those are always really good. Is that necessary? I mean, if you're a data lens to it, sure. If we're doing things that, we're trying to use one variable to explain another, that definitely could be something that we want to use. And if you can use it, I would suggest that you do. Is it necessary for a successful project? Not necessarily, right? We're more interested in understanding um, what the story is here, right? You really want to understand kind of what's going on with the data. So you can do it as simple as looking at density plots between variables. Or histograms, things of that nature. Those I think are at minimum kind of what we're looking for. But if you want to be a little bit extra, you can throw in a line of best fit if you have a scatter plot here, and particularly showing if you've got differences in groups, right? Showing that data somehow ornamenting it, by color or by different data points, goes quite a long way. And then conclusions. Um, what did you learn, right? I'm not looking for really necessarily statistical significance here, but right, what did you learn about the data? Did you find anything? Were your priors confirmed? Uh, or were there insights that were previously unknown by you or others, discovered here? So what might be a good idea in your conclusion, right, is just do a quick Google search, right? Right, and just see kind of if there's any, or you can throw it into Chat GPT or Claude, just see like what research is there around, let's say, school funding and um, socioeconomic status and racial disparities, right? Like what's the research consensus? Give me some sources, right? And you can kind of get an idea, like, all right, so what are the academic professionals and the researchers saying about this particular topic, and did you come to a similar conclusion as they did? Um, yeah, 928.
I do have a question.
Yes, ma'am.
Ideally, how many graphs would you want to see of our question?
I don't know. That's a good question. That's fair. We got one, two, three, four, five, six, seven. So there's seven. I'd say this is like a high A paper. What was the other one we looked at? What we got here? Online. What did Amina do? Sure, Amina's share this one up. So she also, she's got one, two, three, four. She got four. One's got four. One's got seven. I mean, um, you should at least have one slide that like describes your data, right? Like it sort of like a introductory, just plot the data, just show the audience what the data looks like, whether it's a scatter plot or bar plot, whatever. Um, and then you should have further drill downs in your data. Um, I guess like what's it out? So a table of summary statistics. So there's one output, and then maybe like minimum you should like four, I guess. I don't know. If it takes you more, it takes you more, right? But it should take you, I'm guessing, right around, at minimum four to really tell a complete story, right? So you're probably going to have like your like one, kind of showing the summary of the data, like your big kind of here's all the data plot, and then you're probably going to have some like filtering or like you're going to focus on something. So there's probably another one or two there, and then you may have like a conclusion plot, right? That kind of summarizes what your findings are. Like there's four, and then you may have some other stuff in there too. So Um, if you're doing anything with geographic data, right? So there's a map plot, right, showing your averages was like so it's kind of like a heat map literally on a map, right? So if you're doing like county level data and you've got like blue equals like low and red equals a high value, and it's each county is shaded by these low and high values, kind of like what they did here, right? But as like a stack bar kind of a thing, or a stack column going across here by region, right? Um, but yeah, I mean, use your judgment. I'm not grading by weight, so don't feel like you have to like stuff this thing full of charts. Like the last thing I want to do is I call it death by charts, right? Like you're just going to chart pack me to death. Um, that's a really common thing for people to do. It's like, here's 73 slides over a really simple question. Like, to just give me like boil down to like five, right? Like, use as many as you need to, I guess, sort of answer your question. And if you get to a point where you're like, hey, look, this seems a little thin, dude, feel free to ask, get my opinion, right? I'll definitely tell you, like, look, you really need to expand on here, or maybe there's something in your question that you didn't go down, but would be an easy lift, and that could really help kind of blow it out. I know I gave you a total non-answer, and I apologize. Somewhere between somewhere around the vicinity of four. If you give me more than four, I'm happy. If you give me three, but they're like really like deep, that's also good. Um, and if you don't want to leave it to chance and you want to ask, like, hey, here's my deck, can you just give me some feedback on it? I am also playing the role of advisor mentor for you guys this semester. So feel free to ask if you have any questions about kind of how things are shaping up.
Thank you.
Yep.
I had a quick question.
Yes, ma'am.
So you sent the project update too. Were we supposed
Yes.
to do that document on top of the slideshow presentation?
Yeah, if you could just like kind of just fill that out, like one that's going to help me like understand like where your questions are going. And then two, it's going to help you kind of focus your attention a little bit more directly. The census data stuff is, as I'm sure you guys are aware, like a really, really huge data set. It can be a little hairy getting through it at first and trying to come up with something to focus on. And I feel that those updates, like the first one where you're talking about the question, the second update where you're actually getting the data, really go a long way to help kind of draw your attention into like a productive deck. Um, and that, I mean, to be quite frank, is like the hardest part of presenting any kind of economic data, right? Like you've got all the data in the known universe at your disposal, right? Plus all the most advanced tools to be able to analyze it. Okay, so what are we going to talk about, right? And and these things really help provide focus, so that way you're having a very productive conversation. And again, this is about telling a story. I don't want you guys thinking like, oh, I got to come up with some Nobel Prize winning insight here. No, like this is tell a story, like explore a question, like show me what you got, like show me some charts, right? Have fun with it. Take some, and hopefully the question is right in an area that you have some sort of personal interest in, or something that you want a path that you want your education to go. Anything else, guys? We good?
What
Oh,
day are we presenting again?
Thursday. We present Thursday.
Thursday. Okay.
Yep. Thursday. The presentation length should be like 10 minutes. I mean, I'm not looking for like a full discussion here, right? Like really just walk us through your data, your methodology, right? I may ask you a couple questions about kind of the work that you did. But really this is about kind of, again, just sort of telling the story. It doesn't have to be exhaustive. 10 minutes is not a whole lot of time as you start getting into stuff. And so I think, it's a pretty fair, right, expectation. Anything else, guys? We good?
Do you have time to talk after class?
I do. Absolutely. Actually, we're like 5 minutes over. So unless anyone else has other questions, you guys are good. And Johnny and I will hang back.
Okay,
Thank
cool.
you.
Thank you.
Awesome. Thank you guys. Let me go ahead and stop recording.